So this one is DC electricity pop quiz 6. In the first question, driver uses the car headlights to emit light in a dark conditions. As you can see, a graph is there. Remember, if we have an IV graph, what the slope represent, the slope is reciprocal of the resistance, because if a current is on y-axis, then the voltage is on x-axis. So the slope is reciprocal of the resistance. So if the slope is decreasing, it means the resistance is increasing, and this should be like a filament length. So obviously, it should show this relation. The headlights will emit a light when it dissipate at least 35 watts of power. Determine the minimum potential for which the headlights will emit the light. So we want a minimum potential or minimum voltage when these headlights will emit out. So like, because power is a product of voltage and current, P is equals to VI. So what we want the power to be 35. So you have to check the graph, and that is about minimum. Like example, if you check, so if you check, like say if you took 6, and this is 3.2, 10 boxes equals to 1, so each is representing. So 6 and 3.2, so this is 3.2 and this one is 6. So 6 multiplied by 3.2, that will give us about 18.6. Sorry, 19.2, because 0.2 multiplied by 6, so it will be 19.2. So 19.2 means it is not sufficient, because we want the minimum power to be 35. Means the product of voltage and current should be 35. So this is not giving the result. So if you check 9 here, so this one is 9 and this is about, like this is between 3.678, so this is about 3.95. So when you multiply them, you will get the minimum power. So you have to use the graph, and you by the product of voltage and current should be 35. Means you're finding the part of a graph in which the product is 35. So P equals VI. So voltage and current, you will get the answers, and the product which is 35, like 35 is there, or you can also do, yeah, you can also do another thing, like you can work out from your graph as well. Like take any current and use the power to be because you want the power to be 35, so you just divide. P is equals to VI, so power divided by current, you will get the voltage, and then that voltage be the answer. So the correct answer, 9 volts. When the potential is 9 volt, then it will give a power of 35. In a car, two headlights are connected in parallel to a 12-volt battery. The battery has a negligible internal resistance. Explain advantage of connecting headlight in parallel with a battery rather than in series. So we have a 12-volt battery is there, and we connect these headlights in parallel. So connection first, whenever they're connected in parallel, they will work independently. And the second thing, they receive the same voltage, because if the operating voltage is 12, so they both receive 12 volts. Otherwise, if they were connected in series, the potential will divide, so the voltage across each will be 6 in that case. So receive the same potential and work independently. And when they receive, like as you can see here, if they have current is the power is a product of voltage and current, or if you have two lamps, identical lamps are there. So we have the formula P is equals to I square R. So what will happen as the value of because when they are connected in series, the combined resistance of a circuit will increase, but the power of the circuit is constant. So the current, as a result, what will happen? They will have a smaller current. The power is constant. And another advantage you can also refer. So in parallel, as they will have greater voltage will be there, so they will have a greater brightness, because in parallel P's resistance is same. So P is equals to V square over R. And when they are connected in parallel, resistance of a circuit is less, smaller resistance, so they will have more power. So you can refer 3 points. One is they will receive the same potential. Another one is work independently. Another one in parallel, the brightness will be greater. For identical lamps, when they are connected in parallel, they will have a greater brightness as compared to that in series. A student writes the following statement: when connect to a 12-volt battery, the combined resistance of two headlights in parallel is 1/4 of a combined resistance in series. Deduce whether the student is correct, and your answer should include calculation using a data from the graph. So we already work out the voltage, like when they're connected in parallel, first we work out the resistance of each, and when they're connected in parallel, it will be product divided by sum. So when the voltage is 12, so we first find the current, which is 4.6, and the voltage as they're connected in parallel. First, we are finding the resistance of individual lamp, and then we'll find the combined. So resistance for individual lamp, R is equals to V over I. So voltage was 12 and this is 4.6, so 2.61. 2.61 ohm is a resistance of one lamp. But two lamps are connected in parallel, so combine it for two in parallel, it will be product divided by sum. So 2.61 into 2.61, the product divided by 2.61 plus 2.61. This will give us the combined in parallel, which is 1.305. Okay. So 1.305. This is for a parallel combination. Then in series, we just, to get the combined resistance, we will add. So it will be 2.61 plus 2.61, which is 5.22. But the thing is, the resistance, as you can see from the graph, the resistance is not constant. 2.61 plus 2.61, 5.22. But I just realized that the graph was not like when the current voltage graph was plotted, it was not a straight line, it was a curve. So it means if the voltage changes, the current is changing, so resistance is also changing. If it was a straight line, means I can use the same resistance. But now when they're connected in series, they will have a different. So if they're connected to a 12-volt supply, the identical lamps are there, so the total 12-volt will divide 6 and 6. So now we are finding the resistance of each lamp when they are connected in series. So 6 divided by the current. So how much is the current when the voltage is 6? So current is 3.2. Why I repeat? Because if it is not a constant resistance for us, for lamp, it changes when the voltage changes. So 6 divided by 3.2, that will give us the resistance of each, which is 1.88 ohm. So this will be 1.88 and this also 1.88. So this will give us 3.76. So when they are connected in parallel, it is 1.305. When they are connected in series, it is 3.76, the combined. Now read the statement. According to statement, when the two lamps are connected, when connected to 12 volt, the combined resistance of headlight in parallel is 1/4 of the combined resistance of two headlights in series. So mean in parallel is 1/4 in series. So means like this value, 1.305 combined resistance in parallel is 1/4 of combined resistance in series, like 3.76 divided by 4. 3.76 divided by 4. What's the answer? 3.76 divided by 4. This was parallel and this is series. 0.94. So 1.305 and this is 0.94. So this does not match the statement. So student statement is not correct. Is it clear how we did this question? So first we find why we took different resistance when in series or parallel, even though the identical component, because this identical component, if the voltage is changing, the resistance will also change. So the student statement is not correct. Then the headlights are connected in series using a copper wire. Calculate the drift speed of electron in a copper wire, the number of the charge carrier, resistivity. So we have the formula, the transport equation, I equals N A V Q. And where R is a resistance, I is the current, N is the charge density, which we have, this is N. This is resistivity is given, resistance over length is given, resistance per unit length, and the current is also given. Because the area, we have this formula, R is equals to rho L by A. So if we need area, so area is equals to rho L divided by R. And if we further simplify, so we can say area is equals to rho, it will be R divided by L. But you can substitute like per unit length. So length is 1 meter. You can, even if you are confused, you can substitute these values. So resistivity is there. This is resistivity. We substitute resistivity. It is per unit length, 1 meter. So length we substitute. And resistance is there. So we substitute. We'll get A. After getting A, I is there. This I is given. Number of the charge per unit volume is given. Area we calculated. Q is the charge of electron. So we can work out the drift speed, which is I divided by N A Q. That will give us a B. So we can get the drift speed. Is it clear, this one? So we just have to substitute the values to get the drift speed. So this was a pop quiz related to the DC electricity.